So I'm going to do some more right triangle similarity. So I am just going to continue on the next page in my spiral. But first, I think it's good to just get a little more practice again with what the whole storyline is here. So we have a right triangle. So I'm going to try and draw a right triangle here. And so let's say this is our right triangle, and we are going to drop an altitude right here, which makes a right angle. And when we do that, we end up making two interior right triangles, and all three of those are similar. So they don't have to be named ABC, so I'm going to call this one MATH for math. So I want to just go through and highlight the three triangles. So we have the original triangle, which I like to call him Papa Bear. So we have Papa Bear here. Papa Bear's right angle is A. His short leg is AM. His long leg is AT. And his hypotenuse is TM. Then we have Mama Bear, and Mama Bear is this one over here. Mama Bear, her right angle is H, right here. Her short leg is HA. Her long leg is HT. And her hypotenuse, so the hypotenuse of Mama Bear, is the long leg of Papa Bear. Then we have Baby Bear, and his right angle is also H because he was formed when we dropped that altitude right there. His short leg is HM. His long leg is HA. His hypotenuse is AM. So Baby Bear's hypotenuse is Papa Bear's short leg. So remember, Papa Bear is made out of three hypotenuses. So his hypotenuse, his long leg is Mama Bear's hypotenuse, his short leg is Baby Bear's hypotenuse, which I think makes perfect sense. And then there's a relationship between Mama Bear and Baby Bear. They share this side right here. Well, this side is Baby Bear's long leg and Mama Bear's short leg, which again, I think makes perfect sense. All right, so now for our example, let's say that I am going to tell you that AT is 9. So AT is 9. I'm going to tell you that HT is 4. HT is 4. And I want for us to find MH. So find MH. Okay, so let's see what this gives us here. All right, so AT is 9. So AT is part of Papa Bear. So AT is 9. But since it's part of Papa Bear, I know it's also going to be related to Mama Bear because the long leg is her hypotenuse. Then I know that HT is 4, which is part of Mama Bear, and that one is not shared in any other triangles. And then we're looking for MH, which I can see is part of Baby Bear, which is not shared in any other triangle either. All right, so now we're at a situation where we have one side of Papa Bear, two sides of Mama Bear, one side of Baby Bear. So something needs to happen here, and we can't figure out anything over here because we have a side of Baby Bear, but we don't really. We can't figure out anything else over here. We have one side. But right here, we have two sides of a right triangle. So there's something called Pythagorean theorem that hopefully you remember. And Pythagorean theorem is a formula that allows us to find a missing side of a right triangle if we know two sides, and we do. So I'm going to kind of go over here. So Pythagorean theorem says a squared plus b squared equals c squared. So a squared, I don't know. B squared is 4 squared. And c squared is going to be 9 squared. And I know that the legs are the a and the b, and the hypotenuse is always the c. So I'm going to do some scratch work over here. So a squared plus 16 equals 81, which means a squared must equal 65, which means a is going to be the square root of 65, which I know I can estimate to be about 8.1, but I'm actually going to leave it as the square root of 65 because that's going to end up being a little bit easier. In just a second, you'll see. So we just figured out that this side right here is the square root of 65, and I can see by my markings that this side is shared over here is on Baby Bear. So now looking at this, I have two sides of Baby Bear and Mama Bear that are corresponding. So I'm actually not even going to use this 9, so I'm going to erase it. And then I also don't even need the Papa Bear over here at all because I now have corresponding sides with Mama Bear and Baby Bear. So I'm going to go ahead and write the proportion here. So I'm going to say Mama Bear first. So long leg over short leg of Mama Bear is going to equal long leg over short leg. So long leg over short leg of Baby Bear. So I have long leg, short leg of Mama Bear, and then long leg, short leg of Baby Bear. All right, so now in order to solve, I certainly have no idea how this is going to get to that, but I know I can multiply the diagonals. So 4 times x would be 4x. And this is why I left it as the square root of 65, because the square root of 65 multiplied by itself is just 65. So that's certainly a lot easier than multiplying 8.1 by 8.1, which is just an estimated answer anyhow. So divide both sides by 4, so we get 65 over 4, which is the same thing as 16 and 1/4. So now I know that MH, which is right here, which is our missing side, is 16 and 1/4. So that would be the worst case if you were working with the right triangles where you had to use Pythagorean theorem in order to even set up a proportion. But I also want to take a minute to tell you or show you something very cool about Pythagorean theorem since we were talking about it. There is another way, another use of Pythagorean theorem, and I don't know if your teacher from last year mentioned this or not, but not only do you know that a squared plus b squared equals c squared works for right triangles, but have you ever thought about what happens if a squared plus b squared is bigger than c squared? Or what if a squared plus b squared is smaller than c squared? Because surely you know that somebody in math figured out what's happening here. And I'm about to tell you, it's very cool and it's very simple. It might be opposite of what you think, but if you start thinking about it, it will make sense. If a squared plus b squared is bigger than c squared, then you have an acute triangle. And if a squared plus b squared is smaller than c squared, you have an obtuse triangle. And that is just a neat little side thing, another use of Pythagorean theorem. If a squared plus b squared is equal to c squared, that's a right triangle, and that's what you learned and what you've used the most. But there are these two other situations where, well, what happens if it's bigger or what happens if it's smaller? So that gives you an idea of another way that you can use Pythagorean theorem.